let me show you this in a little detail in here. So what do we have in syllabus? So the first one is basically aerial photographs and their interpretation. Okay, so the interpretation part usually will go under elements of photo interpretation. Okay, so this question was asked in this year's civil services mains exam as well. Okay, so if you go through like elements of photo interpretation, aerial photographs and their interpretations, merits and limitations. So in the limitations part anyway, I have given you notes of these limitations of remote sensing in general. So you can write a generic answer of what are limitations of remote sensing. There only it will go. Okay, so for this one, this chapter there is in your course I've given you an NCERT chapter. Okay, so which you have to go through. There is an entire chapter. So just read that chapter on aerial photographs. So sometimes in previous year questions they asked the difference between a map and aerial photograph and all those. Basically everything is covered in that NCERT chapter. Okay. Also, I've given you basically introductory slides to introduction to remote sensing. Okay, so introduction to remote sensing directly they will not give you in the syllabus. So you just go through that slide. No need to like spend too much time memorizing things. Basically, what is remote sensing is getting information about an object without actually touching the object itself. Okay, so you will need a source of radiation somehow. Okay, so it could be a natural source such as sun, or it could be an artificial source, which is in, for example, in case of a radar. Okay, and then there will be a target, and then there will be a receiver. Okay, and when in between, because the electromagnetic radiation is traveling, it will travel through atmosphere. So some atmospheric interaction will be there. Okay, so you have basically target. Okay, then you have a source here. Sorry, target will be on the ground. Okay, you have a source, and then you will have a receiver. In between there is atmosphere. Okay, now this source can be natural or artificial. Okay, natural, for example, it can be sun, or it can be earth itself. Okay, so if it is sun, sometimes actually I should not write here. Okay, earth here. So usually it is sun. I will say where earth will actually go to come into picture. Okay, and this is the reflected radiation, which will be received by receiver. In between you have atmosphere. Okay, in the atmosphere there is atmospheric interaction. Okay, so this is where the concept of atmospheric windows will come into picture. Okay, so this question was also asked in this year 21 mains examination, if you've gone through it. Okay, atmospheric windows. Okay, so you have source, target, and receiver. So there is a source, target, there will be some interaction, there will be some interaction in atmosphere. So that part you just very briefly go through. I've added slides to that part. You'll find some brief video lectures as well. If you can understand the slides enough, if you have, for example, I think most of you would know what basically is absorption, reflection, all those things. Okay, so you can directly go through the slides as well. Okay. In electromagnetic spectrum, okay, it is, I think most of you have studied it in very basic science class as well. Okay, so it is just what is gamma ray, for example. You start with X-ray, ultraviolet, visible, infrared, microwave, radio wave. So that will be in the electromagnetic spectrum. So you have to study that, and this will be related to atmospheric windows, which I will explain in a while what they are. Okay, so this will be related to atmospheric windows. Orbiting satellites and sensor systems. Orbiting satellites you would have studied in your GS preparation as well. So for example, what are geostationary satellites, geosynchronous, sun synchronous satellites. So near Earth orbits are there. There are some which are far Earth orbits. So those satellites have to basically go through. So just go through the slides as quickly as possible. And then these center sensor systems. Okay, so for this there are basically 2 chapters from NCERT book. Okay, which I have added. So you don't have to read entire NCERT. So there are 2 specific chapters. So for this also I've added NCERT. You will find there is a video lecture as well for this one. Okay, so just go through these. So in sensors, basically they can ask you about sensor systems. Sensor resolution is also important. Okay, resolution in terms of, for example, if you have a sensor, one thing you all are aware of is like resolution. You take pictures from your cell, let's say even cell phone. So some cell phone cameras have higher resolution, some have lower resolution. So that resolution term, okay, which we are speaking in that term is called spatial resolution. Okay, spatial resolution is if 2 objects are very close to one another, can you differentiate between them as being separate objects? Okay, so for example, if I draw 2 dots here from close, okay, so now if I bring it very close, you will see 2 dots. If I take it very far away, you may see just that there is just 1 dot in here. So this is called spatial resolution. Okay, so if 2 objects are very close. So similarly, you can have resolution in time as well. That will be called temporal resolution. Okay, so for example, if a satellite comes to the same spot every 3 hours, so your spatial resolution becomes 3 hours. If it will come to the same spot every 1 year, so then your temporal resolution will be 1 year. So it will be how if 2 events are spaced close to one another in time, that will be temporal resolution. Sometimes it can be related to brightness also. Okay, so for example, the worst kind of resolution in terms of brightness, that is called radiometric resolution, will be if a system tells that this is white object, this is black object. Okay, but if it can tell, okay, this is a little bit darker, this is even a little bit more darker. Okay, so like that will be radiometric resolution. It will be shades of gray. So you can have different types of sensor resolution. So you just go through the writing. So you'll find this discussed in NCERT as well. Okay, so study that part. And then there are certain types of, what is called basically in sensors. Okay, so for example, I will explain. So you have seen 2 kinds of, I will say in real life, 2 kinds of sensors you would have seen. Okay, one is a camera. Okay, so a camera, which basically, if this is the scene, a camera will capture this entire scene in 1 instant. Okay, so this is also called a framing camera. It will frame the entire scene in one go. Okay, But sometimes you would have gone to a photocopy machine as well. Okay, so when you're doing photocopy, you would have always noticed that there is a line here, okay, which moves through this. So it will, there is a page, it does not take picture of that page, it scans through that page like this, a line. Okay, so instead of capturing entire scene in one go, it captures the scene line by line. Okay, so this thing is called a scanner. Okay, this thing is called a scanner, and we will have two kinds of this you have seen in photocopies. In case of remote sensing, there is another kind of scanner which instead of going line by line, it goes point by point. Okay, so it may scan the entire scene like this, point by point. Okay, like this. So it will go to this point, then this point, then this. Okay, so for example, this will be called a push broom scanner, push broom or line scanner. Okay, why push broom? Because we would have seen, for example, a mop. If you want to clean the floor in your house, you have a mop. It is all kind of a push broom which will push through the room. That is why it is called push broom. Okay, this one, okay, this is also called opto mechanical line scanner. Okay, so also called whisk broom or optomechanical line scanner. So okay, these you have to study basically. So what this automechanical line scanner will do is, it will, if you have to capture a scene, okay, so it is also called whisk broom. Why? Because you have this kind of a broom. So either you can use a mop or you can use jhadu, right? What is the motion of jhadu? So it is even a push broom will go in one line like this. Okay, so it is capturing an entire line and then it is moving forward to capture the scene. So push broom will do is like if this is an, let's say, a satellite or an aircraft. Okay, and these are important because later on you'll study about Indian remote sensing satellites as well. Okay, so let's say this is an aircraft. Okay, so in that aircraft, okay, so you can capture the entire scene, for example, like this, one line like this, and then that aircraft will be moving forward. Okay, so this is this direction which is moving along the track is called along track direction, and this is called across track. Okay, so it's like a push broom. Okay, you're pushing that broom. How will you do jhadu? Okay, this broom, it is like this kind of a motion, oscillating motion, right? So that is this is the push broom one. So the other one, which is optomechanical line scanner, will scan in this manner basically. Okay, so like this, it will be an oscillating motion like this. So it will move in that direction and it will have that oscillating mirror. So basically how that mirror goes is, so it basically keeps revolving like this. Okay, so whenever it will, the scanner will come down, it will scan like this. So it will have that oscillating mirror. Okay, so this is what you have to study in those scanners. Okay, all right. uh, Indian remote sensing satellites. Okay, so for example, this you have studied as part of general studies as well. You would have heard about Cartosat, Indian remote sensing satellites, IRS series. Okay, so all this is covered in this part. Now, it can be a little extensive to memorize. So study it after you've studied sensors and you have studied basically different types of electromagnetic spectra. Okay, electromagnetic spectra, for example, what is electromagnetic spectra of vegetation? There you will study about different infrared radiation. Okay, classification. So I'll come to that part. But I provided you notes, so directly you need to study it from the notes. There is a 20-minute video lecture as well, which you can go through very quickly. Usually you'll find, for example, Cartosat series, Cartosat 2, 3, 1. Okay, so usually there will, if you memorize one in next generation, there will be one or two additional features that you have to memorize in that part. Okay, so usually a question generally does come from this part. Okay, which is quite frequent. Satellite data and products, again, just go through NCRT. Basically, you can have different types. Applications of remote sensing in geology. This is a general question, so they can ask you remote sensing, GIS, GPS. Usually, there is a significant overlap. If you prepare answer for one, you think of your answer is done for most of them. And basically, if even if you don't study it, okay, you write from what you know already from your GS preparation, it is more than sufficient. Okay, so for example, in disaster management, advantages would be, applications would be in groundwater. For example, it could be in mineral exploration, disaster management, flood control, for example, tsunami and all those things, early warning systems. Maybe it may not be directly related to this, but damage assessment. Okay, assessing health of forest, croplands, all those will come under these applications. Okay, so just go through that once. Okay, don't waste too much time on this. Even if you write a generic answer, it will be good enough. You can memorize 2 or 3 points basically once you'll go through the previous part. So for example, when you're studying vegetation, so you'll study spectral signature of vegetation, then you can go through, write a few points on that, but you'll find content for all this stuff. Okay, and then advantages and limitations also. So limitation of remote sensing, for example, you are viewing it from the distance, you're not actually touching the object, so it is indirect measurement, not direct measurement. So those kind of limitations also you just study once. Okay, geographic information systems, GIS, it is almost all every time this is asked. Okay, so usually they will ask you 3 kind of questions from this. One is applications part, another could be working. So basically it is called triangulation. Okay, how do you triangulate a position? So if you know distance from one satellite, so it will be, for example, if it is 100 kilometer from one satellite, it can be in 100-kilometer radius. Let me explain this. Okay, what triangulation is. So if you know distance from one point is 100 kilometer, okay, you know that the object of interest is at 100 kilometers. Okay, now let's say you have second satellite, and the same principle works for earthquake also. Okay, so how do we locate an earthquake? So you have different earthquake stations around the earth, and they can triangulate the position where the epicenter of the earthquake was or where the focus of the earthquake was, basically by getting the distance. So let's say from another satellite it is at 200 kilometers. Okay, so now your possibility is just these 2 points. Okay, and now if you have a third station and that says like this, so you have pinpointed the location. Okay, let's say third station says that the distance is 250 kilometers. Okay, so it's the same principle works for GPS as well as for earthquakes. Another is, so this is working. Okay, this will go under working. Another thing that they can ask you is in this GPS system is basically components of GPS, which they asked this year. Okay, so basically in the working only, as when you're studying working principle, what are the components, okay, of a GPS system? Okay, so there'll be, for example, receiver. So imagine what is happening with your cell phone. You have cell phone handheld device in your, which is communicating with the satellite, and then there will be a base station with which that is communicating. So those components you have to study. Just go through that. Okay, applications will be very similar. Okay, there maybe you can add military applications, but even military applications, remote sensing also has. So it is pretty similar to what remote sensing applications are there. So don't get confused. Don't think that you have to write something special. Okay, you have to prepare, you have to strategize in a short period of time. So you prepare a generic answer for GPS, GIS, remote sensing, what applications you're going to write in those. It will be pretty similar for all three. Okay, so this is what strategy you need to follow. Basically read those 2 chapters of NCRT, very important. It's not entire NCRT, it is just 2 chapters. Okay, so go through video lectures for spectral signature of soil, vegetation and water. I'll come to this. Basically spectral signature, you'll see it is not directly mentioned here, but it is asked in the exams. Okay, so it is part of this electromagnetic spectrum only. Okay, or interaction, okay, of electromagnetic radiation with objects. Okay, this year they asked this question also. Okay, so three are most important: vegetation, water and soil. Okay, these three you have to study. So what is spectral signature is, okay, so I'll explain that to you also in a while. So when you go through those chapters, another important concept is this atmospheric windows concept. Okay, so this concept of atmospheric windows, so this is also like studied in introductory remote sensing class only, and you also know it informally. What is atmospheric window? Okay, so for example, you know, if I'm standing on the surface of earth, can ultraviolet rays reach me? Okay, they cannot reach completely. Why? Because a lot of them are actually blocked. Okay, so anything that you see in this red zone is blocked. Okay, now you know what blocks those radiation. Okay, it is ozone which blocks that ultraviolet radiation. You can see here everything that is in red here is blocked. When you're seeing this kind of diagram, a little bit you have to care, you have to see sometimes transmission is given here, sometimes opacity is given. So transmission is opposite of opacity. If something is opaque, it means that radiation will not be transmitted. So basically what atmospheric window is doing is remote sensing. You are sensing from satellite or airplane, and you have earth. So the radiation has to travel from sensor to the earth. Okay, sorry, so from source to earth and then back to target. So that transmission is happening through atmosphere. Now atmosphere, we think it is transparent because we see invisible region. So this is visible region in here. So you can see there is almost 100% transmission in visible region. Okay, we have evolved to see in this region. Okay, if it was blocked, then eyes would have evolved to basically see in whatever region it is transparent. Okay, so visible region can go through atmosphere without significant absorption. There is very little or no absorption in the visible region. Okay, in the atmosphere. Similarly, UV rays, they get absorbed by ozone, which is present in the atmosphere. Now another thing that you all know is, for example, this is long range infrared. So you would have studied about it. Okay, greenhouse gas effect. So you can see here, this is radiance. I plotted here energy which is available from sun. Okay, this is black body radiation of earth. Earth also, anything black body radiation, what it says is anything which is above 0 Kelvin will emit radiation. Okay, if it is at lower temperature, okay, that is what is called Wien's displacement law in physics. Okay, we'll not go into too much details, but earth emits radiation at much higher wavelength than the sun because earth is at lower temperature. And you see a lot of radiation emitted by earth, okay, is blocked. Okay, so the radiation which is coming from the sun, this kind of infrared radiation which causes heat, a lot of this is actually transmitted here. Okay, so you have multiple bands in here. Okay, but you can see this is called near infrared, short wave infrared. This is far infrared, and this is thermal infrared. Thermal infrared is one which is producing heat. So what happens is energy from sun can come, but it cannot go back. That is how why we get greenhouse gas effect. Okay, so basically you all know this particular part. You have studied it. Okay, this is just formalizing that and going technical. This part also, okay, is all in radio waves. Okay, so this is all radio waves. MW, microwave and radio wave. Now radio wave signals from your dish antenna, for example, you have to communicate with satellites. Okay, you get TV signal in your home, you have a Wi-Fi is in microwave region. So if atmosphere was opaque to these, you would not be able to have any of that technology. Okay, so you know about these. Radar, for example, works in microwave and radio wave region with which you can detect enemy airplanes. Okay, so atmosphere is transparent in that region as well. So this is how you can memorize. Okay, so basically you know all this stuff. Here you just have to memorize this figure. This is very important. Okay, all right, so we have gone through these. Okay, also this you will find in where you study spectral signature. Okay, so a lot of actually in remote sensing is done in infrared region also. Okay, so we have visible region, red, green, blue. So this is important because this will maybe they will not directly ask you in the answer, but for example when you're studying spectral signature, when you're studying atmospheric windows, okay, so there you need to know what is this infrared radiation. Visible, you know, visible is 400 nanometer wavelength to 700 nanometer. Sometimes we will write it as 0.4 micrometer to 7.7 micrometer or 0.75 micrometer. After 0.75, your infrared will start. So that infrared can be divided. So here you write it just 1000. There is a smaller in here. So you write it far infrared can go up to 1000 micrometer. That is approximately 1 millimeter. Okay, so a wavelength of 1 millimeter is in that far infrared region. Okay, after that microwave will start. Okay, So you see 1 millimeter, then microwave will be in centimeters, and in radio waves will go from, can be several meters. Okay, that is why we use that wavelength for transmission. For example, why you have Wi-Fi in your home is the wavelength is large. So large wavelength means it can move through objects, okay, which are physical real world objects. If I'm standing in this room and in that other room, for example, that microwave can go through diffraction, and also it can go through walls as well. Okay, walls are transparent to that, so they become very large wavelengths in that region. So we have to focus on infrared region, and this thermal infrared is basically within these. There is a region called thermal infrared, which is from 8 to 14 micrometer, which you usually use for images from aircraft. When we're talking about satellites, we have a slightly narrow region. Okay, so you will have different bands when you have remote sensing satellite. Okay, so when you're studying about Indian remote sensing satellites, there they will tell you different bands. Okay, so for example, you may have a band in green color, in blue color. Okay, in blue color usually we don't have, so green or red color, and then you may have bands in this infrared regions, different. So you'll have to study about those bands. Okay, for Indian remote sensing satellites. So there is what is called a LIS sensor, LISS. So you just need to know that LIS sensor for IRS series, Indian remote sensing satellite series, and that it will have bands in these different regions. Okay, so I will now just show you basically what is there in the course itself. Okay, especially I just want to, so I've given you these basic content. So here I've uploaded this NCRT, some additional content, handwritten notes you may find in these NCRTs also. Okay, so to prepare for your any answer. Okay, so for example, this question was asked previously in one of the papers, aerial photograph versus map difference. Okay, so scale of a map, etc. You just basically go through this, and then there is a chapter on remote sensing where you will basically be able to find many different things. Okay, so just go through this. This basic introduction is there to remote sensing. What I was telling you about electromagnetic spectrum is there. This they can ask in the exam. Okay, this one is not given in detail, but this is called spectral signature. Okay, which I was talking about. This is spectral signature of vegetation. Okay, so for this there is a there are detailed slides. Just go through those. Okay. These are different types of orbits. Okay, so that is again important. So I've you'll find some handwritten notes as well in here. Okay, different sensors I was expecting. So sometimes you'll have these panchromatic sensors, multispectral and hyperspectral. Okay, these will also come into picture. They can ask you difference between them. So panchromatic is like a black and white image. Multispectral is a colored image. Okay, because there you have red, green, blue. Okay, uh, hyperspectral is where you will have basically thousands of bands. Okay, so for example, when you're seeing a colored camera, it has only 3 bands: red, green, blue. That will give you colored image. Some remote sensing satellites can have 7, 8 bands. In some they can have some bands in infrared region, but some of them will have hundreds or even thousands of bands. Okay, so instead of just looking at that, so you can create these curve, this kind of a curve which you see here. Okay, so this kind of a curve, this is a continuous curve, you know. So for example, if there are 3 bands only, so you will get one value here, second value here, third value here. So then one here, so you will get a discontinuous curve. So if you want to get continuous curve, you need very narrow bands. So you will have a very high spectral resolution. I told you there can be different kinds of resolution. One of them is spectral resolution, is what wavelengths of light can you differentiate between one another. Okay, so if you can say if one is like one micrometer, another is 1.001 micrometer, and you can differentiate between them, that gives you high spectral resolution. So those will be hyperspectral images. Okay, so you will find content regarding that. Okay, so first chapter, all those everything is there. Okay, so slides, introduction and all. You can skip through video part if you are, you know, like what is infrared, what is visible, what is X-ray, and all those things. Okay, this spectral signature is important. Okay, so I explained it to you. I'm not putting video lecture here because it will be too much for you, but what you have to see is, for example, this is spectral signature for vegetation. So it will tell you how much of that is reflected in a given region. Okay, so now we know vegetation leaves appear green in color. It means, so this is visible region here. You see, in visible region, leaves actually absorb a lot of radiation, which makes sense because they have to make food. To absorb, they have to absorb sunlight and make food. Okay, but you see a small reflectance peak at green color. That is why they will appear in green. Now we cannot see infrared, but if you could see infrared, leaves will appear shiny, very bright in infrared. Okay, so they can basically reflect a lot of radiation, so they will appear very bright in that. So this is what, just you have to memorize this curve. Okay, and just very basic reason why that is happening here. The reason is leaf pigments. You have pigments in leaf, for example, chlorophyll absorbs visible light. It will reflect a little bit in green region. Okay, this one is cellular structure is the reason, cells. Okay, and for this we will study spectral signature of water. So water absorbs in these bands very strongly. So this is water absorption. Okay, so you just have to memorize this. This is the main part. Okay, then you can basically explain it in your own words also. So you have to memorize these. This you just go through one detail, but again just need to go through that. NDY is normalized difference vegetation index. Okay, this is to determine health of vegetation. This you can write in applications of remote sensing. That's why I've included it here. It is nothing. It just wants to see how high this peak is. This jump, this is also called a red edge. Okay, so if this red edge is very significant, it means your vegetation is healthy. So it is just this value minus this value divided by this value plus this value. Okay, that's it. That is what NDVI is. Near infrared minus red, near infrared plus red. Okay, then there is soil. Okay, soil, you know, appears brownish in color a little bit. Okay, if iron oxide is there, it will appear reddish in color. If organic content is there, it will be black in color. Or if it is derived from basalt, that will also impart black color to soil. Okay, so this is what you have to study in here. Okay, overall spectral signature here also you have to study. So for example, this is spectral signature of soil. Okay, this is basically different kinds of soil. This is minimally altered soil. So basically you can see here, this is the visible region. So green plus red, it does not reflect in blue region. So green plus red, it is slightly reddish. So that is why soil appears brown in color, and it keeps on increasing around this part. Okay, so these bands that you see here, soil will have water in it. So the same bands that you're seeing in vegetation because of water, you will see here as well. Okay, overall this is kind of pattern. So you have to basically memorize that. Okay, so C is iron dominant soil. So you can see here this red band is quite significant in this one. Okay, What will affect moisture content in soil will affect it. Okay, if there is moisture, soil will absorb radiation, a lot of radiation. Water, you have to remember that water absorbs a lot of radiation. That is why we say that if the polar ice caps melt, okay, so polar ice sheets, they reflect 90% of the radiation. Water absorbs 90% of the radiation, especially in that infrared region. So that becomes important. Okay, so soil moisture content, you just memorize that part. Okay, that is most important one. And just look at these features. Okay, there is some description of these. Just go through that. Organic content will make soil black in color, so it will absorb a lot of visible radiation. Okay, so just one line you write from slides, what is the impact of these things. And finally, there is water, spectral signature of water. So you can see here, water has very low reflectance, but water is transparent, so a lot of radiation can go into water. Okay, but it will keep going, and then it will get absorbed. Okay, if there is a deep water body, if the water body is shallow, water may not absorb anything or reflect anything. Water may not reflect. So but the flow, for example, if you have a shallow lake or pond, so light can get reflected from the base of that pond. That can happen. Okay, so deep water bodies will appear black in color, but shallow water bodies will appear bright in color. Okay, so there are basically basic causes of variability, so just learn about this. Okay, so some chlorophyll, for example, can make it go green in color. Some tannins, which are plant products, they can make it appear brownish in color. Okay, so just go through that. So these three curves you memorize, because you can draw these curves in hyperspectral imaging, because in hyperspectral imaging you get data points by wavelength very close to one another, so you can recreate this curve. So you can draw these curves in when you're explaining hyperspectral images as well. Okay, satellite sensors, I've already explained this, push broom, whisk broom, so you just go through this part. Okay, GPS, GIS. Okay, so just go through. There are video lectures. If you want to go through those, you can go, but otherwise you can just go through slides as well. Okay, and this is important because usually you can get a direct question from this. Write a note on Indian remote sensors, satellite, Cartosat or RISAT. So I've given you handwritten notes for this part. Okay, so if you've gone through previous lectures properly, if you know what a band means, what infrared means, so you have different bands in here, so you just have to memorize, especially for remote sensing satellites. Okay, so just go through those. Okay, so for example, green, red, near infrared, mid infrared, so those kind of bands are there. So handwritten notes are there, you just memorize that. And you see basically different series remote sensing satellite. There are Indian remote sensing satellite series, there is resource sat, and then there is IRS. So you can basically memorize this table as well. Okay, so you will see, when you're studying this, write at least those wavelengths in your notebook. You will see patterns in that. Okay, so that will become, so there is a 20-minute video lecture also, you can go through that as well for this part, because it is quite short. Okay, so you go through these parts, your syllabus for remote sensing will be done. Try to finish it in one day. Okay, wherever you can generalize, especially in the application part, you can write a generic answer, absolutely no problem with that. Okay, when you're writing application part, don't try to overthink that I have to write something special in GIS, GPS. You can, okay, some special basically, but I think if you go through the content, you're smart enough, if you have come up to this stage, that you'll be able to understand the part. Okay, so thank you all very much, and wish you